follows on from the last one, and now we're going to take the problem and try and make it dynamic, and by that I mean be able to vary the distance that the two cyclists are apart and the speeds that both of them travel at. But first I'd just like to sort of think about each of these cyclist speeds, and here these graphs, they go into the negative x territory on both of them, and really that doesn't really exist. So I thought it would just be tidy if we could sort of limit each of the graphs to start from 0. And the way we can do that is just to take this here and hover your mouse over the function and to right click, and it says copy to input bar. So we're now going to copy this function down into the input bar like that. And if you highlight in front of it and type the word function, and then start with a square bracket, and then if you have the function first, and then if you put it after a comma, if you put where you would like the function to start from, I suppose a domain, it would be 0. And in this case, where I'd like it to go to, well, I suppose you could choose, say, 120 minutes for 2 hours. But for me, I suppose I'll choose infinity, so it can go forever, and close with a square bracket, and just insert that like that. And then if I turn the function off above, there we are, we've limited it to just starting at the point where x equals 0. And so we'll do the same to y. We'll copy it to the input bar. We'll put the word function, and we'll put it inside this expression here with the square brackets. And then after we have the function, we'll put a comma, and I'd like it once again to start at 0, and using right out here on the right hand side of the input bar, there's a little set of characters to do infinity, and hit that. And then you can also turn off the function in the top, and there we are, we have the two functions, but they're only starting from 0 now. And also, just at the moment, I might take away this dependent object, the point where they intersect, because we'll put that together. So now what I'd like to do is I'd actually like to add some slide and make the problem dynamic. So just clicking here next to the mover, and it's a slider, and you can click anywhere inside the window, the pane here. So I'll click over here on the left, and up will come a dialog box. And so first I'll put in a distance slider, and let's say I'm interested in the cyclist starting from anywhere between, say, well, we could go from 0, possibly not realistic because they'd be at the same point, but let's say they could be a 0 to 100 kilometers apart. And we put apply, and there we are, and now we have a distance slider, and as you see, just sliding along it, it can go out to 100. Now we want to insert that into the equation, and here it is at the moment in this function here at the moment, and it's at 40 where they started. We would like to change that to the word distance. So if you right click on that and go down to object properties, and here it is here, and I'm just going to take the number 40 out and put the word distance in, and I'm just hitting return and close. And now, well, now they are both at 0, so they just, I suppose that's correct in a way, they just immediately diverge and go their own ways and never meet. But if we take, and we can now vary the distance. So, but as you see, I'd like to change the y-axis to get the scale more correct, because you can now go up to 100. So if I just drag that down, holding the left mouse button down, and there we are up to 100. And I might just drag the axes over a bit like that as well. And so now you can see we can, going back to the slider, which you need to highlight for them to be active, and you go back up to being 100 kilometers apart down to 0. And now we'd like to be able to vary the speeds of each of the cyclists as well. So I suppose we'll do the speed of x first, so clicking on the slider and just clicking anywhere in the pane again, and you highlight, and up comes the slider box, and we can say speed of A. And thinking about this, how fast can a cyclist go? Well, so let's say they can go as slow as, well, they can be stopped at 0 kilometers an hour. And they can go up to, I don't know, 60, is that reasonable? I mean, that's pretty quick for a cyclist, but we'll say up to 60, and we'll apply that. And there we now have a slider that will let the speed, I've put speed A there now, we want speed X. So once again, we can just go into object properties, and we can change that to speed X like that, so that makes a bit more sense, and that's changed to speed X. Now, we need to put speed x into the dependent object, into the equation, where at the moment it's travelling, x was travelling at 30 kilometres an hour. Well, now we want to just take 30 kilometres out and put speed x in there. So we go to object properties. And here we have 30. We've divided it by 60 because we wanted to make kilometres per hour into kilometres per minute. But now if we just put speed x in there, and we just close that like that. And now, you see, there we go. The speed varies as you use the slider. And we'll do the same, highlighting the slider again. We'll add a slider in again, and we'll type in, this time we're dealing with speed of y. Once again, well, let's say this cyclist is a similar sort of cyclist to cyclist X, and this cyclist can ride up to 60 kilometres an hour as well. We'll apply that. And once again, we'll go into the equation here, and that's this equation here at the moment. And we'll right click on the equation and we go down to changing the properties. And here, instead of 20 kilometres an hour, that will now be a variable which is speed y. And we'll close that. And at the moment it's travelling at 1, which is virtually flat, but as you see, as it accelerates, it will begin to approach x, or 0. So now we can find the point where these two, the dependent point where they two both intersect. So clicking on this point here, intersect two objects, and we click there, and we can see at the moment if they're 67 kilometres apart and x is travelling at 60 kilometres an hour and y is travelling at 55.8 kilometres an hour, well, they'll meet after 34.72 minutes, so 34, almost 35 minutes, and they'll be 34 kilometres from x. And you can change each of these variables, clicking back on the sliders to make them active, and you can change each of these variables, and so you can begin to experiment with different distances apart and the cyclists travelling at different speeds for this particular problem.